Thank you! We got over 100,000 subscribers on the AirShaper YouTube channel, which means we got this nice silver play button from YouTube. So in this video, we're gonna look back into the past and see all of the cool stuff that we did thanks to your support and how we can actually use your feedback to make cool new videos to keep you entertained. So let's dive into the past. So we started off with the very elementary things like what is a drag coefficient, where does drag come from, how does a diffuser work, what is a wingtip vortex, and so on. Then we started playing around on this old Volkswagen Beetle. We made our own vortex generators, which was a lot of fun to see how it works, and it actually did work. We covered drone aerodynamics. We took a deep dive into athletics by 3D scanning a cyclist or triathlete actually and analyzing his position. We worked on city vehicles, electric vehicles already 7-8 years back. Then what we did is we worked on airplane aerodynamics, and then the Tesla Tesla Semi was released. We quickly made a 3D model together with our partner Voxdale and analyzed the aerodynamics. We worked on race cars, the Porsche GT4, to see how we can improve the cooling. We explained how CFD basically works. We actually then looked at some regulations, how to cut the drag on trucks. Race cars, we're quite fond of race cars, so we did a video on what an aero map looks like, which means how can you map the aerodynamic forces, air balance, front, rear. We did interviews, we looked at hypercars, supercars, rally car aerodynamics. We interviewed people at Airbus, which is really cool. We got to talk about their wind tunnel setup and so on, how they support the America's Cup. We interviewed Louis Vermeers, who's a very well-known car designer. He was the head of design at Pininfarina and now has his own grand studio, design studio. We interviewed the folks at MV Agusta on their work on the MotoGP series. We explained how to use ParaView, which is an open source software environment to visualize CFD data, very useful. We looked at other hypercars like the Gordon Murray T50 with the active aerodynamics with the fan. We looked at golf ball dimples. That question comes up every once in a while. We looked at how wind tunnels work, which means how can you look at the different segments of a wind tunnel? What are the typical errors? How can you do measurements? How can you run coast down testing, which is to slow down your car and then analyze the drag forces? We looked at how you can automatically optimize the shape by having the software improve your design. Looked at pitot tubes to measure flow, velocity and pressures. We analyzed real cars in real life. So we took a Porsche Taycan for a spin, put some tufts on it to analyze the airflow patterns. We looked at boundary layers, flow separation, so again back to the theory. We analyzed a Ford F-150 pickup truck and tried to modify it to actually cut the drag by over 20%, which means cutting the range by around 10%. Then we went to look at tidal turbines, which is a completely different domain, but we do hydrodynamics as well now. We interviewed NASA to analyze what they're doing on the electric aircraft. We looked at how they optimize the propellers, foldable propellers, and so on. We had a bit of fun analyzing the aerodynamics of the Top Gun movie. Really cool, quite a lot of interesting deviations from reality there. We did reverse engineering on the Rivian R1T. We actually did a video also on this hypercar. This is a modified Lamborghini for which we did the entire aero package. It's already been tested at 447 kilometers an hour, so stay tuned, we're gonna do some more. We then did a community design challenge where you, as our subscriber, were able to provide input on how we should actually improve the design of this formula car to reduce the drag, to improve the downforce and so on. We did the same for MotoGP. We got to teach aerodynamics at San Diego State University, which is really rewarding, together with Professor Joseph Katz. He wrote the book Race Car Engineering. Really do check that out. We visited Robin Shute, who is the king of the mountain of Pikes Peak, won it 4 times already, is now using AirShaper. And we looked at the Tesla Cybertruck, how to improve or analyze the aerodynamics. We went to visit NASA, which is really cool, got to visit the location where they actually designed many of the X-planes and tested them. Got to teach at UCLA in Los Angeles, test drive the hyper-futuristic Aptera, which is this electric solar vehicle. And we got to visit NASA again, a different site, to analyze or to sit inside their space shuttle simulator, really cool, the vertical motion simulator. And then we went on to explain how we can run CFD simulations on different applications like trucks, cars, motorbikes, and so on. And how we can actually use software to give you advice on how to cut the drag or increase the downforce on different areas, and go even further by having the software optimize the shape automatically to cut the drag. We did a reverse engineering on the Tesla Cybertruck using a precise 3D scan, and we went to car shows and so on to cover the Koenigsegg, to cover the Pininfarina and Battista and so on. And we ended with this last bit of our video, which is actually this one. This is our propeller blade, really cool thing. We analyzed it using 3D scanning and so on to analyze how it performs 8 years, or how it used to perform 8 years back. So that's what we did in the past, but now the main question is, what do you want us to do in the future? We can dive into hydrodynamics, into aerodynamics, as we did before. We can do more cars, we can do airplanes, we can do drones, we can do anything you want. So please do drop a comment with what you think is the coolest topic that we should cover to actually make you happy for the next 8 years on this channel. So again, thanks a lot for supporting us over the past 8 years, and we're looking forward to your comments on what to do next. Have a great time. Talk to you soon. Bye bye.